Hey, what's up everybody? Welcome to part 3 of this series that I'm doing on designing and cutting out some benches for my Burning Man camp. So this is the part 3 video. So in this video I'm going to be going over the process to create the toolpaths in Fusion 360 and then export the G code. If there's a little bit of time at the end, maybe I'll tack on a little stuff at the end. But for the most part, it's just going to be the process of generating the G code. And what I mean by that is I'm going to generate the code to drive the CNC machine. So this is called CAM. It's Computer Aided Manufacturing. And I'm going to be doing this in Fusion 360. So if we just jump over real quick to what that looks like. So I use a paid version of Fusion 360. This is, I paid for this out of pocket. It's not sponsored. I think some of these features might not be in the free version anymore. They were a number of years ago, but I'm not too up to date on what the free version allows for and doesn't allow for. So if you don't see some of these features, just know that it could be in the paid version and not the free version. I think the Fusion folks still allow you to do a free trial for potentially up to a year for a hobbyist. So I'm not really sure how all the pricing tiers work, but it's pretty cheap and pretty affordable. So if there's a feature you need that you don't see, then it might be worth it to just get the subscription or find a workaround. So what I'm going to do is I'm going to start by first of all saying that at the beginning of this video, I'll put in cards up in the corner, maybe over here somewhere, for the first 2 videos in this series. If there's follow-up videos, I'll try to put those up there too. Those videos will also be found in the links to those videos in the description, as well as a link to this design for sale on my website. I'm trying to sell this design. Maybe you'll also see on the website some raw unfinished wood cutouts, because I might have that for sale also. I do not sell finished products anymore. It's a little bit too labor intensive for the purpose of what I'm doing. I'm just trying to do the design and the prototyping, and then let you guys finish the rest. However, having said that, I do have a finishing video currently in the works. So if you're catching this video shortly after it's posted, it's probably not up yet, but it should be soon. Let's say summer of 2023 at some point. So that's a lot of being around the bush. At the end, I'll also put some links to those other videos, related videos at the end of this video. So now we are 3 minutes in of me blathering on about that. Let me go ahead and get started with the real content. So the first thing I want to talk about is the router bit that I'm going to use. I like to get this stuff out of the way at first. So let me just jump over to the browser here. Let me pull it up. Let's see. Excuse me one moment. Okay, so you see my little cursor. I guess maybe you can't see my cursor, but you can see me hovering. All right, so this is the router bit that I'm going to link to in the description. This is basically my favorite router bit for cutting out plywood. I don't know if I can recommend it for anything other than wood. But honestly, for wood, it's so affordable. It's so cheap. Some router bits can get pretty expensive. Some machining bits can get pretty expensive. And the nice thing about this one is it has this, what you'll see is it's called a compression bit. And what you can see down here is you can see the very tip of the flutes actually has, it spirals the helix in a different direction. So what this does is it actually prevents tear-outs, because on your very first pass in the plywood, if you go down, I believe the compression area is 1/4 of an inch. We'll probably have this little, maybe they don't say. Oh yeah, the MH here, right? Mortise height, 530 seconds. So basically what it's saying is you want to get to a depth of more than 530 seconds on the first pass, excuse me there. So let me do my calculator. You guys can't see this on screen, but 530 seconds is 0.217 inches. So if you know that off the top of your head, good for you. I don't know 30 seconds off the top of my head. But basically what that means is you want your first pass with this router bit to be 1/4 of an inch or deeper. And then you'll be into the, past that mortise height. So that's really important. And then the other thing is on your final pass, that'll help pull the wood up and then prevent tear-outs on both the top and the bottom by using this bit. Now, the other thing is that you might be like, well, $25 bit, that's pretty cheap. How long is this thing going to last? How well is it going to cut? And I will tell you, it can last a very long time, and it can cut really well. And I will actually need to pull up another window real quick. So I'm going to pause, and I'll be right back. And we're back. Okay, so I had to pull up this web page that I didn't have previously pulled up. So this is really critical. This router bit chip load chart is basically the driving factor behind a lot of what we're going to do for programming today in terms of how we're going to make sure our router bit lasts a really long time. So let me explain. When you're cutting with a router bit, if you spin too fast, and router bits tend to spin super fast, and you go too slow, it creates a lot of heat and it creates a lot of friction. And then what ends up happening is the router bit overheats, and then once it overheats, the carbide gets softer, or I'm not exactly sure the chemistry or mechanics behind it, but basically it dulls out the bit really fast. Hot router bits or hot cutting bits don't last very long. So what you want to do is you want to keep it cool. Now we're cutting wood, so we're not using a water cooling system like what might be on metal machining. So really the only option, well maybe not the only option, but the only economical option is to use the material itself, that is the wood that you're cutting, as the coolant for the router bit. And the way that you do that is you take off bigger cuts. So every time your router bit takes a nice big cut, the wood, which is at ambient room temperature, is helping to keep the router bit cool. You're getting less friction buildup because, it's less of a rubbing and scraping and more of like a cutting action. And I suppose in theory, the amount of energy that you're putting into the system is the same or even more, but you're putting a lot of that heat energy into the wood that is being cut away, and then that chip is now, the wood chip is now warmer than it was before, and it's being removed from the area of the router bit. So let's say your average hobby class router machine probably is running between 14 and 20,000 RPM. Generally speaking, we want these to be running on the lower end of what they're capable of, or middle end. Hopefully you have RPM control. Maybe you just know the range on the router body, I guess that you would say, that you're using, and you just put the setting somewhere in the middle. For our purposes, let's assume that we're running 14,000 RPM. It's a good number. It could be around 15 or 16, but let's just assume 14. That's right in the middle of this chart. And what you'll see here is that you want a chip load of around, now they're highlighting the 7, 8, 9, up to 10. I don't know if they're going up to 12. It doesn't look like they're going up to 12. You can see that they're not going all the way up to 12. They're highlighting in green 7, 8, 9, 10, and 11 thousandths for chip load. They're saying at the top here that you can go as high as 17 thousandths, but what you're running into at those higher chip loads is you're running into a lot more stress on the machine, a lot more stress on your router head and the bearing. There's going to be a lot more load on the bearings. And of course the other thing is that you only have so much power. So a lot of the routers that I'm assuming you folks are using are more of a hobby class router. Let's say anything that costs under $20,000, anything that doesn't have a water cooled head on it. All of these are going to be, in my opinion, pretty power limited, which is why we select the 1/4 inch 2-flute bit on the front end. If you're running a 3-flute bit, you got to hit these same chip loads, which means you're running a lot faster, and it takes a lot more power. You're cutting 50% more material, right, per second. So we stick with, and my personal recommendation is sticking with a 2 or maybe even a single flute bit. They do make single flute bits at the smaller sizes. I prefer a 2-flute bit at a 1/4 inch diameter. And then what you're going to do is you're going to aim for somewhere in this 7, 8, 9 thousandths range. Part of the reason that I'm aiming for the lower end is that, again, we're running into power issues. I don't want to be plowing the machine through at a high rate, taking off a lot of material really fast, otherwise known as the material removal rate, and then trying to almost max out the power that the machine can deliver, because it's just not good. You can run into issues, right? Because then maybe you're pushing too hard and you push the plywood, or you blow a circuit breaker, or the machine literally cannot keep up. It literally does not have the power to cut fast enough. So all these things are considerations. Now, the router that I use, it just recently moved locations. In the old location, the power circuitry seemed to be able to handle it a little better, and in the new location, the lights get pretty dim. So I'm gonna probably program this to take maybe 4 passes instead of 3 passes. In the past, I've done 3 passes. Now I'm gonna do 4 passes. Maybe run it a little bit slower, a little bit closer to this 7 thousandths range. So again, that's a lot of talk. End result, you need to take off larger chips to keep your tool cool, and then you'll cut lots of sheets of plywood from one tool bit, and everybody's happy. So what I'm going to do is I'm going to aim for this number right here, the 7 thousandths at 14,000 RPM, which means 200 inches a minute. And this is the part that over here that really matters. I've run as high as 250 or 300. It really depends on the setup of the machine, but for this purpose, we're going to do 200. And for the machinists out there, especially machinists who have done work in aluminum and especially steel, this is going to sound very fast, because it is. This thing's cruising. This machine is going to haul through the wood. That's just the nature of doing wood router cutting. Is you got to go fast. It really is the best way to do it. And I did a really huge project before I knew this, and we went through a lot of bits. I've spent like $500 on tool bits that were getting dull after like 5 sheets of plywood, and it was all just because I was running it too slow. I was also using 1/2 inch bits. I couldn't run them faster. The machine couldn't keep up. And yeah, it was very expensive, and I could have saved a lot of money if I knew this back then, and I knew to use a smaller router bit. The other thing is, some people might say, well, a 1/4 inch router bit isn't going to hold a tight tolerance. That might be true, right? Maybe we have a little bit of flexibility on the tip of that bit. But honestly, again, wood, I mean, you're cutting with a pretty hard steel. There really isn't a big factor for flexibility. And if you really are that concerned about it, you can always slow the machine down in the area that you need to have precise cuts. And you can always go up to like a 3/8 bit instead of a 1/4 inch bit. And maybe these are ways for you to sort of split the difference. But anyways, we're almost 15 minutes in, and I haven't shown you anything about how to actually set up Fusion for this. So let's go jump over to Fusion, and we will get started. Whoa, yeah, there we go. See how I'm recording this? Yeah, so just in case you get a look behind the curtain there, I use OBS Studio or I guess it's OB Studio? Anyways, yeah, that was my little screen capture program. All right, here we are, over in Fusion. So this is the cut layout I did on the last video, and what we're going to do is we're just going to start. So you see, this is, we're in design. We're going to jump on over to manufacture. And I might do some other episodes. I really like the rendering in Fusion. I might do a video on rendering, but for this one, we're going to do manufacture. I'm not going to do a live webinar. I'm doing a webinar, effectively. All right, so you know, I'm going to spend maybe a little bit of time explaining what some of these terms mean, but for the most part, I'm going to try to get through this in the next 40 minutes or so. So I don't want to spend too much time dwelling on some of the stuff. So first of all, I'm just looking at my origin. My model origin is right in the middle. That is how I want it. For modeling purposes, it's on the bottom plane there. And you can see that I put in a piece of plywood here, right? So let's start with doing some modifications. I just wanted to see where that was, but we don't need it. So I'm going to turn that off, and I'm going to take a look right here at the components, right? So actually what we need to do maybe is hide this and then save. I'm gonna fumble a little bit with this because I don't have a ton of experience. Normally I would just delete it, but I'm gonna try to keep it. All right, so setups. This is where we start. This is where all of CNC machining starts with a setup, where basically you're telling the machine how your stock, like a sheet of plywood is the stock that you're going to cut these parts out of, how that is oriented on the machine. So let's go setup here. So the very first thing is you need to know the axis coordinate system of your machine. This is super critical. Most routers that I know of have the z-axis as the spindle, and then I'm gonna actually think here for a minute. I believe positive x is the 4-foot direction and positive y is the 8-foot direction. So what I like to do is I'm going to show you this first. Let's see, is it collecting? Oh yeah, it does. It does think that it does think that that piece of plywood is in there. Okay, so right now what it's doing is it's assuming that the stock, which is this box, this like shaded box, encompasses all the parts, and that is including even though I hid the plywood, that is including, let's show the plywood, that's including this, all right? So it's putting all the parts in there. And what we want actually is we want it to ignore that plywood. We want it to just cut out the parts. The plywood is just a reference for us. Now we can do this in two ways. I believe we can ignore the plywood model somewhere in CAM here. I'll have to find that. I might have to pause again in a moment. The other way is we can just literally delete the plywood out of the model. I don't want to do that because I had that set up in the last video. I don't want to already like just undo what I had already done. So let me quickly search how to ignore that, and I will be right back. I'm going to do another pause. I'm probably going to do a couple of these in this video. Be right back. All right, and I'm back, and I don't have a great solution. So what I'm going to do is I'm going to try to work around it rather than ignore it. So hopefully this is fairly easy. So we're going to go over here to setup. And I think one of the things, and maybe, you know, maybe this is not a great way to do this, but we're going to do model. And we should be able to just select the components that we want. And I don't know that I love this method because then you have to select all the components that you want to do machining on, and yeah, that's a kind of a pain. So maybe we don't want to do it like that, but that's what I want to do right now. The other thing is we're going to select a machine. So we're going to do a generic 3-axis where generic 3-axis router and Y, X, Z, X, Y, Z. Sure, we'll select that. You know what? Actually, I don't think we need this. We probably don't even need to do the machine model. I think that's not necessary. We're going to do milling, and then we're going to do stock box. So this is a work coordinate system. We're going to select Z and x-axis. So what we're going to do is the z-axis is going to be over there in the corner. And then the x-axis right here is going to be this edge here. And origin stock box point. We're going to throw it select the point right there. And we're going to flip X. So there we go. So what this is doing is this is putting the origin right in this corner. Now I'm going to try to show you a little trick that hopefully this makes sense. So let's assume that this plywood at the bottom here is just the bed of our machine, and then we're only doing the stock on top of the bed. So what you'll see that I'm doing is I'm doing the origin on the bed of the machine. And I know a lot of people like to do the origin on the top of the material. I like to do it on the bed because I don't have a lot of control over the thickness of the plywood. And the machine that I use has a spoil board, so it's going to cut down into the bed of the machine just a little bit into that spoil board. And what I like to do is I like to control that height more than I want to control the thickness of the plywood. If the plywood varies thickness by 20 thousandths, I don't really care, but I don't want my my router bit to be cutting into the spoil board 20 thousandths more than it otherwise has to. So for that reason, I always do my origin off of the bed of the machine. Okay, so what is the problem with this? The problem with this is a lot of machines have a go to home button and big go to home. And that can very easily cause your tool to then crash into your stock if it tries to drive down into the bed of the machine. So we don't like that. So here's a workaround that I just sort of recently came up with. I haven't really tried it yet, but I think it's a good plan. So you'll see over here in stock, what we can do is it says, how big is the stock? Relative stock, fixed size box. So this is useful for if your stock for your part is just like a little bit bigger than the part, or if you know the size of your stock to begin with. So we know the size of our stock. It's not 46 inches, it's 48 inches because it is 96 inches long too, because it is 4 feet by 8 feet. And now you can see that it basically lines up almost perfectly over the plywood that's already there. Height is 0.75. And there it is, perfect. So here's the clever trick that I have just sort of recently thought of. Now this might depend on if your machine has more travel in the Z or X axis. Otherwise, but here's the deal, right? If we say it's 96.5, right? Clever, half an inch. What that's going to do is it's going to push us, this should be a 1/4 inch right here, a 1/4 inch distance, the stock is off. So what this means is that when we go to set up our machine, if we actually put 0 for cutting out the part on the edge of our plywood, right, what it's going to do is then if we hit the home button, it won't drive into our stock. It'll drive into nothing. It'll just touch off the bottom of the machine. But then when we go to cut it, it's just going to shift everything just a 1/4 inch closer to the edge, right? A 1/4 inch closer to this edge. But we've already given ourselves a pretty good margin here, so a 1/4 inch closer to the edge is going to be fine, right? In theory, that's how this is going to work, in theory. And actually, because I'm making the stock a little bit larger, I'm saying the stock is larger than it actually is. When I put that bit there, it should not really appreciably move. I guess it'll technically move by 1/8 of an inch, right? Because we're talking about the radius, not the diameter. Maybe what I should do is, I'm getting a little bit deep here, But if I say it's only um, a 1/4 inch, then basically if I line the tool up on the z-axis, right, so I touch off this corner, um, then I hit the home button, it shouldn't drive into the plywood. I think I'm gonna actually want to do more like, I don't know, what makes sense here? The 1/2 inch was nice. Let's just stick with a 1/2 inch because that's really gonna be fine. Because we don't need to have it cut exactly perfectly on the plywood. I'm gonna click OK. So then the other thing is, you may also be wondering, and this is another thing that I've learned, is what I'm going to do in this video is I'm going to show you some other tricks of the trade. So sometimes in the past I had a machine that it might lose its position for a variety of reasons. Maybe you tripped a circuit breaker because you're driving it too hard. Maybe it plowed through the material too fast and it just couldn't keep up and it stalled out. Maybe you had to hit the E-stop and when you hit the E-stop it loses its position. So it's a really good idea to do, it's a really good idea to have reference points drilled into your plywood before you start cutting. So let's hop on over to design and I will show you how to do reference points. And the reason I didn't do this in the previous video is because this is really all about machining technique, right? So this is real simple. You just select your part there and you just create a sketch and then you just throw a little circle here. I like to do these little donuts. Maybe one down here. And then throw a dimension on this. This is going to be a 1/4 inch, 0.25. We'll make this an inch. And then we will make this a 1/4 inch. I could just equal them to the other ones, but it's a little bit easier to do it like this. All right, so then what I'm going to do is I'm going to go, you here are tangent, and then you are tangent to here. And then I'm going to do tangent here, tangent here. So now we know that these holes are an inch spaced off of the edges of the plywood, right? I guess 1/2 inch, because it's an inch diameter. So let's call it, actually, it might make more sense to go 2 inches here, if it still fits. Just to give ourselves a little more breathing room. Now you'll also realize, of course, we'll go finish sketch. We're going to actually extrude. You're going to go up 0.75. Oh, but we want to actually edit feature. I want to grab this one too. All right, and then we save. And then we go back to manufacture. Now it's gonna, well, I guess we didn't do any toolpaths, so it's not gonna be angry, but sometimes it could be angry if we change a part up. If we changed our part, it would be like, oh, this toolpath is no longer valid. But then we're gonna go back to edit the setup, because if you remember correctly, we looked at this. We're gonna click to add these two guys. We're gonna click oh, yeah, that's an interesting question, right? Because if we go back to this, oh, but it's centered. All right, so what we have to do is we have to look over here, make sure that still fits. Which does. Actually, this isn't bad. This is actually a good thing, because that what that means is that we're gonna zero off the part. We're gonna zero over here, which is artificially gonna move everything a little bit closer to this edge. If you're not following, that's fine. I'm just gonna actually, basically what I'm saying right now is that because there's a gap here, I have enough space, and because it still fits over here, I have enough space. All the parts I care about are enclosed in this box, and that's really all you need to know. The bonus is we have a little bit of a bigger margin on this side than the other side. And we have 48 by 96, 3/4 inch. I don't know what this round up to the nearest is. I don't want to round at all, so we can say 0.25 and then click OK. All right, so we're already basically half an hour in. I haven't done a single toolpath, so let's make sure that I cover toolpaths. So the way that I generally do this is there's a lot of different types of operations. The big ones are face milling, clearing, and then contour, right? These are the three big ones, especially for 2D manufacturing like this. I don't really have a lot of 3D features. So I'm not going to get into a lot of these more complicated things because really this is just a simple project. So what I'm going to start with is I'm going to start with, it's tricky, right? Because like this is the question is, where do we start machining, right? Which part do we start cutting out first? And I'm inclined to think that we want to cut out the legs and the brace and get all those parts cut out before we do anything on the top. And the reason that I think that is because, the reason I think that is because these parts are going to provide a lot of support for cutting out these parts. And while in theory these parts are also providing support for cutting out these parts, I think we can do this in a way where actually we don't need the support from the legs and the braces. So what I'm going to start with is I'm going to start with doing contour, because all of these parts are contour cuts. Tool. Now, I don't really get super picky into different tool types in Fusion 360. It just isn't something that I necessarily need to spend a lot of energy on because I don't do tool changes. I really only do one tool. I cut the whole thing out with one tool. So this is ultra simple setup, right? And oh, so I go in the library, right? They did change this from what it used to be. It's a little bit different. Cutting tools, inch. No data. Where's my data? Okay, so milling tools. Here we go. All right, milling. Flat. Diameter. Units, inches. 0.25. Boom, there it is. And this one had a flute length of 0.75 inches. So, oh, look, they have a couple different aluminum, brass, copper, steel, plastic. They do not have wood. And let's see. Probably the plastic is the one that we start with. Cutting data. So this is disabled. I guess I don't exactly know why, but let's select this tool. We'll just fix it over here. That might be an advanced feature. I might need to copy it over into a custom library first. I'm not exactly sure. I'm going to ignore it for right now, but basically the important part is we have a 1/4 inch flat end mill. We're not even going to do coolant. Spindle speed is again 14,000 RPM. We talked about that earlier. Um, surface speed 200. Oh, cutting feed rate. Actually, this is the one we want, 200. Feed per tooth. 200 inches per minute. Oh, I'm sorry. The surface speed is being calculated based off of spindle speed. So let's go back to 14,000 RPM. There's a lot of settings. Oh man. So what happens is sometimes I'll hit enter, and it'll be like, okay, you're done with this thing, and then it'll try to exit out of it when I hit enter, and that's a mistake. I don't mean to do that. So except I typed in 140,000. Okay, so 14,000. Cutting feed rate 200 inches a minute. So it's saying for almost 5,000, maybe we're gonna do 220, 250. Maybe it was 250. I thought that chart, that chip load chart was. Oh, you know what I gotta look at? I gotta look at number of flutes. Right? Does it know? It's got to know how many flutes. Well, I don't know. I don't know where it is. I don't know where it is. But this is, oh, info, probably. End mill, coolant, flat end mill, number of flutes. There it is. That's why the calculation is off, because it says it's 3, but it's actually 2. It used to be easy to edit this, but I feel like I'm having a hard time figuring out how to edit it right now. Doesn't matter. Doesn't matter, because we know that it's 2 flute and not 3 flute, and it doesn't really matter if the machine knows it or not. So we're going to make this 200. Okay, I hit enter again. It's trying to go. You're like, oh, you didn't select anything. Okay, so custom, 14,000 RPM, 250, cutting, man, keep editing the wrong thing. It's an amateur hour here. So this is 5 thousandths, but we know that that's calculated based on 3 flutes, so this is 75% more, so it's closer to 8 thousandths. I don't really care about a lot of these numbers. Usually whatever it selects here, anything below this cutting feed rate, or this feed per tooth, I'm not super worried about. You can make these smaller lead-ins. It might be nice to go a little slower, but I'm not super worried about that. All right, so contour selection. So this is where we figure out what are the what are the parts that we want to cut out, and really the important question is, what is the order in which we want to cut them out? So generally speaking, when cutting on sheets of plywood, I like to work from the middle out, and this is in part because you might be clamping it in the corners, right? So we might put a clamp here, we might put a clamp here, and down here, and down here. So we want to be mindful of cutting from the middle, further away from the clamp, towards the clamp. So I'm going to start here, 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 here. And we'll go over to this one, and then this one. And then we'll go this one, and then this one. And we'll go this one, and then this one. And then we'll go this one, and then this one. And, let's just click OK and see what happens. I'm gonna give it a minute. Let's see. Okay, so it looks like it cuts them all out. Now you can see Fusion does this nice thing where it shows you all the stuff that you cut out. And now the cool thing is you can come up here and you can do simulate, and then it will show you, if you click down here where it says play, it'll show you the machine cutting it out. And if you know, you can speed it up or slow it down. I think the true speed, I'm not sure, but I usually run it pretty quick just to watch. So what you're going to notice is there's a couple things to notice. First of all, it's not cutting it out in the order that I specified. And the other thing is it's only doing one pass. So it's plunging all the way down and then cutting out in one pass. And that's not good. We don't want to do that because that is going to cause problems for us. I mean, you can kind of do it on big parts, but big simple parts, but really for these parts it's not good, and it's really just not a good practice. So what we're going to do is we're going to go back into edit this, and we're going to change some of these settings. There's a lot of stuff that you can do in Fusion that I'm not really going to go over right now, tabs in particular. I don't know all these settings. There's just a lot that I'm going to ignore at the moment. Some of these planes, so these are clearance heights, retract height, feed height, top height, bottom height, all this stuff, I'm literally just going to take the defaults. Because what I like to do is I like to say that since the well, I guess I should say I don't like to take the defaults. What I like to do is I like to have these just have a little bit more, 0.5, 0.4. Oh man, I hit enter. I have to be careful, that's like kind of annoying. And then top height, bottom height. Bottom height is 0. We don't want any offset. Top height, let's call that 0. Feed height, 0.2. Retract height, okay. So basically we're just going to go up a little bit higher. Maybe we'll call this 0.3. Yeah, sure. I want to give it a little bit of clearance because I'm actually going to, when I set my machine up, I'm actually going to go a little bit negative. I'm going to set the Z height to be like right up against the bottom. Okay, so passes. So these compensation types are something I'm not going to get into this at all, but I believe this is how you tell the machine if your machine is a little bit worn out. You can have it kind of compensate a little bit, but I do need to find a way to make sure that we're doing conventional milling and not climb milling, because that's just how my machine works better. So let's jump into finish feed rate at 200 is fine. We're not going to repeat a finishing pass. What we need to preserve order. So this is what is what's going to allow it to cut out in the order that I selected. So let's start with that. Let's watch and make sure that that looks correct. So we'll go back to play, cut out the middle one there, cut out the middle one there, this one, and then that one, and then we're just going to do both of those legs, and then both of these legs, that leg, this leg, that leg. Perfect. Okay, that's the order I selected. Exit simulation. So now let's jump into let's go back to edit, and we're going going to jump into passes. So what I like to do is I like to do roughing passes, or maybe actually it's not roughing passes. It's a little bit confusing. This part can get kind of confusing to get it the way that you want. Multiple depths for sure. So the maximum roughing depth is we're gonna do 0.25, right? And then the finishing step down is going to be 1, and the finishing step down height is, I kind of feel like, what does it make sense to do? 50 thousandths? Now the reason I'm doing kind of a large 50 thousandths is a pretty big step down for a finishing step, but the reason that I'm doing a big finishing step is because I don't want to be very sure that I'm not cutting all the way through on the last roughing cut. I want to leave enough material there that I can really do a good finishing pass. And I'm not actually sure that the bed is flat on the machine that I'm going to be running, so this is part of my, I have to compensate for that a little bit. Finish only at final depth. So this is one that I think is this one's really important, is that, and this diagram does not look very helpful, but we do one finishing path at the final depth. Don't really want to use even step downs because I want to get that first cut to be 25 or 0.25. I don't want it to be less than 0.25. Order by depth. So this is an interesting one because, and I think actually I need to do a 2-part video because I'm not going to be able to address all of the important parts in this one video. This is the kind of the basic setup, and we'll do the advanced setup in the next video. So this might actually become important in the next video. Stock to leave. So this is where I get a little bit, there's like, because I use a spoil board and I'm going to do a Z height off of the spoil board, but I want the cuts to actually go a little bit deeper. There's a couple of different ways to do that. I can tell the machine, I can fake it and say that the Z height is lower than it really is. I can also, I don't know, artificially put the Z height a little bit higher. But this is a good one where I can actually do a negative point, let's say, what is it, 15 thousandths of stock to leave. So it should actually cut a little bit deeper, just a hair deeper. I guess the other thing I could do is I could make the stock itself a little bit thicker than 3/4 of an inch. That might also work. Well, no, because then our 0 is all still on the bottom. So yeah, we'll just try this. Smoothing. I'm not going to do that. Feed optimization. I'm not going to do any of that right now. The last one to look at. Well, let's go through this first before we get into the last bit of data. Let's take a look at, first of all, I'm going to hide, let's see if I can, I don't know where the hide stock is right now. Let's look at this. So now it does multiple passes on each part, and that's what we want. So what we can look at is we can then look in here and we can see that we have 3 passes, as we would expect. 1, 2, 3. And if we look really close, look perfectly on the top, what we should see is that the 3rd pass is offset. and it is not. So why isn't it? Go back to here. I mean, maybe it's just multiple finishing passes is the setting. I feel like this really doesn't make a lot of sense, but I remember this being a way that I had done it before. It still didn't work. Let me pause for a moment while I figure this setting out. Alright, jumping back in, I think what we're doing is we're doing roughing passes. So we're going to say that we're doing roughing passes. And then we might also need number of finishing passes, roughing passes, finishing step down, and then finish only at final depth. No rough final. Okay. There we go. Well, the stock came back. So there we have a huge, yeah, it's angry because we have a huge step over. So what we're gonna do is this should really be like 25 thousandths, not like, okay, that looks more like it. However, we don't want the finishing pass every step down. We only want to get the finish at final depth. So try to take that away. Finish only at final depth. Man, so confusing. Okay, I just wrestled with this for like 10 minutes off camera. So I don't have a good answer. I feel like I had set it up correctly and it just wasn't doing what I needed it to do, so I'm totally not sure. And then of course this forgot everything that I had already set up, but we'll take you, we'll select this. Alright, so again, we'll just run through this really quick. 14,000. Yeah, that's gotta stop hitting enter. Cutting feed rates, 200. And we'll just ignore the rest of this for now, because it doesn't really matter. We'll turn off coolant. So I'm just going to show you on one of these legs what the goal is here, because I was able to get it on one of these legs. So first of all, we're going to do right, because this is conventional milling is important for this machine that I'm using. And then I'm going to basically leave all of this untouched. Roughing pass, I'm going to say, again, what we talked about earlier, 25 thousandths of an inch, just one step over, multiple depths. This worked when I did 0.28 instead of 0.25, so I'm not exactly sure. We're going to do one finishing step down, and we're going to finish only at final depth. We're not going to do a rough final, and then this should, we'll ignore this warning right now, this should give us what we want. So here's what it looks like. You can see there are 4 toolpaths in here. There's 1, 2, 3, 4 passes. If we look at the top, where'd it go? It is gone. If we look at the top, we can see that there's a step over. And if we spin it, we can see the step over is only the last one, which should be finish at final depth. Now, one thing that I'm like a little bit having a hard time seeing right now is it looks like there might be a rough final in there, which I don't want. I don't know why it's doing that right now. I didn't do that. Did not do that the last time when I got it to work. So let's go to models. We're going to turn this off. We're going to click here. And yeah, that totally. Oh, I guess. No, I guess the last one. I guess that last cut. It's really hard to see, but I guess that last cut is a little bit deeper, isn't it? See if we look at it from the side. It does look like it's having a final step down there. One of the things that we can do to verify is we can go to simulate and we can watch it, and you can watch. Let's slow it way down. You can watch as it comes in for the final pass. Let's speed it up a little bit. You can watch and see if the final pass leaves material or not. So right now you can see that there's a little bit of material being left there. It's going to go all around and boom, right? We'll do, there it goes, final pass. You can see the last pass it is doing at full depth. You can see there's a little bit of material there that it's cutting off axially and radially. So this is what we want. I have no idea why it wasn't working earlier when I had all of them selected, but this is the toolpath that I want for this program. And then it's done. Cool. So we got to work with one part. In theory, what I should be able to do is I should be able to take this setup that now is working as intended and edit it, and then I should be able to just click, and sometimes it's easier maybe to just do this, you know, get the toolpath, well, not on the top, definitely don't want the top, oh boy, delete that. Add it there. So let's just click OK. This is about retract height. The safe distance is higher than the feed height. I'm not sure why it errored out. I didn't touch those settings. Typically it should be good to go. So what we're going to do is we're just going to watch this simulation, and it's going to go, and we're going to speed it up a lot. It should do 4 passes and then do, yeah, so really this looks like it's working correctly. We'll look at it a little bit closer in the next video. Oh yeah, this is something I need to talk about. So if you just saw right there, the roughing pass, so I'm gonna have to do a follow-up video because there just isn't enough time to go over it right now. You can see that the roughing passes here, they don't go all the way to the next one. What it's doing is the roughing pass would push it into this other part. So this is part of the challenge of doing tool programming and pathing, and you know, there's a little bit of finesse to get this just right. I thought I would actually be able to get through all of this in 1 hour. We are already at an hour and we're only like halfway done. So apparently programming, honestly, like with a little bit of practice, you can crank this out so fast. But trying to show you guys, um, and it's been a little while since I've done this. I actually had to pull up this part that I cut out a couple months ago because this had the toolpath. I had to look it up. I was like, what am I doing wrong? I came into this part that I cut out maybe 6 months ago. This is for the, actually I showed it at the first video. This is for the coffee table I designed. And I went in here and I just went down these settings and I was like, what am I doing wrong? I still don't know. I still don't know why it wasn't working the first time, but it's working now. We got it set up the way we want it set up now. So that's the basics, okay? The very basic, how do we do a setup? How do we do our first toolpath? You know, I would love to take a second hour right now in this moment and just knock this thing out, just get it done, but it's not going to happen. I thought this was going to be a 3-part video series. Actually, I thought it was going to be a 2-part video series. I thought it was going to be, design and then programming. And I was like, design, programming, done, right? But actually, it's design, and then it's laying out the parts to cut, and then it's setting up and getting your first cuts set up and your tool set up and all that stuff picked out. And then number 4 is tool paths and G-code, and then cutting it out on the CNC, and then finishing it, and then you get to do your oh man, how many steps is that? 7 or 8? It's a lot. Nobody said this was easy. All right, so thanks. Actually, people who say it's easy are trying to get your money from you by telling you it's easy and then selling you a course. And I'm not actually going to do that right now. Okay, so I'm a little bit over time. Here's the deal. Here at the end of the video, there's going to be a little title screen. The little screen is going to link to some other videos. Maybe there's going to be one over here for the other videos in the series. Maybe over here is a little subscribe. Do me a favor, if you like this video, if you found this helpful, go ahead and like, get that thumb up there, like and subscribe. It helps me out. If I mentioned anything in this video, and I did, I mentioned the router bits. There's a link in the description to router bits. There's a link to buy this design from my website, because if you don't want to spend 4 hours figuring all this stuff out on your own, and you're like, hey, Martin already did it, I'll throw him a couple bucks just to download this so I can just go and cut out the final part, then yeah, I'd be happy to take a little bit of your money and give you some services in return. And by services, I mean digital goods. I may occasionally also have physical inventory on hand that I will also list on my website. For the most part, I think I said at the beginning of this video, I'm getting away from selling finished goods, but I will sell you the rough cutout parts. And then you can do finishing yourself. And then you can stain it or paint it whatever color you want, have a little bit of fun, do a little bit of DIY stuff, and then golden, right? Okay, so again, thanks for watching, and I will talk to you in the next video. All right, have a good one.